4th divided by 15t. How can we simplify it? Well, it's plain that we can actually divide the numerator and denominator by 3 to get a simplification of the coefficients. So we just are left with 5 downstairs in the denominator. But we can also simplify some of the t's. You see that? Because here I have t to the 4th, which means t times t times t times t, and I have a t downstairs. I can divide the numerator and denominator by 1t. Or you can also remember the laws of exponents. This is actually going to be t to the 4 minus 1 in the exponent, which is t cubed. So in fact, when I make the cancellation, I can think about just reducing this 4 to 3 because I've got a 1t downstairs. When I do that, I get an answer of t cubed over 5, which seems pretty happy, except to remember something important about the original expression that this expression now lacks. Namely, in its denominator, originally we had a t. That means that there's a particular value of t that we are not permitted to put into this expression. And what is that value? Well, plainly, whatever makes the denominator 0. Well, if I have 15t equals 0, the only way that can happen is if t is 0. So t is not allowed to be 0. And that has to follow through even in this case here. Even though here, by itself, we can plug in t equals 0, we know that really we're not allowed to. So I have to put in a proviso that t cannot equal 0, and if I do that, then I can say that this equals that. So the important thing to remember is, if you simplify, you've got to make sure that if you're canceling out some variables, that you're not accidentally losing the fact that some of those variables can't be 0, or some of those values cannot make the denominator equal to 0. Let's take a look at another example. 2 together. Here's a rational expression. It's a quadratic divided by a quadratic. And let's see if we can simplify. Now, it's not clear how to simplify this automatically, so the thing to do is to see if I can factor. Always the key to this business is factoring. When you can factor, then we're golden. If you can't factor, then we are up the mathematical creek without a mathematical paddle. Well, the numerator, you'll notice, is the difference of two perfect squares, and so I automatically know that can be factored as x plus 5 times x minus 5, and you can actually check that out with a little FOIL, and you can actually see that the outside terms and the inside terms add to give 0, so I'm left with just x squared minus 25. Bang. All right, if I factor the denominator, how can I factor that? Well, I'm going to put an x here and x here. This tells me I'm going to have opposite signs because it's negative. For positive, I'd have the same sign. And I need two numbers whose product is 10, and when I subtract them, I get 3 and negative 3 actually, so I'm going to put the 5 here and a 2 here. Check it out. Negative 5x plus 2x is negative 3x, and that's negative 10 when I take the product. Excellent. Now I look at this. Can I simplify? Sure. So I can cancel here. This factor and this factor actually can be simplified and cancel away. So I'm left with just the numerator that's left over, x plus 5, divided by the denominator. That seems great, but to make this really equal, I've got to make sure that I don't accidentally plug in things that would make things go bad. Well, it's plain that the value for x that makes this go bad is when the denominator is 0, which means x equals negative 2. So x cannot equal negative 2. But if you go back to the original one, which I have here, we see that also x cannot equal 5. Because if I plug in 5, you see I'd have a 0 in the denominator. So you always have to make sure that if you're canceling things away, you're not actually introducing some bad stuff. So I have to say x can't equal 5 as well. And so what I see here is that this rational expression equals this rational expression under the understanding that x cannot equal negative 2 and x cannot equal 5. Got to be really careful you don't accidentally cancel away some dangerous points. Well, I need a common denominator. What's the common denominator? I want to find the least common denominator. So I want to find the least common multiple of these two things. And so I better factor that person first. So I factor, what do I see? Well, in the numerator, not much to factor. Denominator, let's hope for the best. X, same sign, they're both positive. Product is going to be 15, add to give 8. That's easy, it's 5 and 3. Okay, good. the second term, which is x divided by x plus 5. Well, I need a common denominator, which I now see I have this factor already in common. So I have to multiply the numerator and denominator of this expression by this term. So remember, if you multiply the numerator and denominator by the same non-zero value, it doesn't change the rational expression because they simplify. But now the base is the same. So here we go. Common denominator, we can actually add. So we add the numerators, put over the denominators. So in the top, I have x minus 2. And let me actually distribute here live. Is that okay? X squared plus 3x. I just distributed there. Oh, maybe I should put parentheses there. You could put parentheses there. That would not be wrong. But it's not necessary. Since I'm adding, I'm just going to add each term. It's only when I'm subtracting that I have to make sure that the negative sign hits everything. Like a little dolphin going, ooh, ooh, ooh. I don't know why I thought of a dolphin. I apologize. Alright, so here we go. Let's simplify. I've got x squared, 3x plus x, 4x, minus 2. All divided by x plus 5 times x plus 3. So, that's the answer. But let's make sure we understand which points are not allowed. Well, that's when the denominator is 0. So x cannot equal negative 5 and negative 3. So as long as you make that rule, we see that, in fact, this sum is equal to that. You could actually multiply out the denominator if you want, because you could write that as x squared plus 8x plus 15. But I don't like doing that. I think that's actually not a great idea because you want to keep things factored whenever you can. In fact, you might actually want to try to factor the numerator. You could try that, but it turns out the numerator cannot be factored. So that effort would have gone unrewarded. It's two rational expressions. I need to get a common denominator. I want to find the least common multiple of the denominators. This actually, when I look at this, I sort of see it really fast. I want to show you how I'm thinking about it so you can start to see it really fast. I see an x plus 4, can't really factor that. This is the difference of two perfect squares. X plus 4, x minus 4, whoa, x plus 4, I've already got that here. That means all I need is a factor of x minus 4 in the numerator and denominator here, and I'm good to go. So in fact, that immediately tells me that I can do a lot of steps at once. Let me write some of these down. I want you to see them all, but I want you to also think through the fact that you can start to see this really quickly. And I think this is a great idea, by the way. The idea of looking at a question and sort of thinking it through all the way for a while, and then start to write stuff down. So many times we're sort of tempted just to start writing stuff, even if we don't even have an idea. Think first, write later. Alright, so plus negative 32 divided by, and I'll factor this, x plus 4, x minus 4. Okay. Well, I see that I have an x plus 4 factor already here, so I just have to multiply the numerator and denominator by x minus 4. And then my denominators are the same. Cool. So, what does this equal? I'll distribute here the little x, so I've got an x squared minus 4x plus negative 32, so that's going to be minus 32. All divided by, and then I see the common denominator of x plus 4 times x minus 4. Alright, well I like things factored. The question is, can the numerator be factored? Let's actually see if we can factor the numerator. It'd be great if we could, wouldn't it? Different signs. Product is 32, and they combine to give negative 4. How about 8 and 4? Negative 32, when you combine them, you get negative 4, x. So this one does factor, which is awesome. Because then I see that, in fact, there's actual simplification. I can actually simplify the factor of x plus 4 on the numerator, x plus 4 on the denominator. This is amazing. This is equals x minus 8 divided by x minus 4. Really, really simple. What are the values we are allowed to take on? Well, all values except when the denominator equals 0, which is when x equals 4. Is that it? No. Remember, you've got to go back to the original expressions. We canceled away this term, but we have to realize that in the original expression, x cannot take on the value negative 4 as well. That's when this equals 0. And so, in fact, that's when this becomes undefined. In fact, that's when this becomes undefined as well. So, in fact, we also have to include, even though it's completely okay here, x can't equal negative 4, where we can see these ideas coming into play all around us. A freight train averages 20 miles per hour traveling to its destination with full cars, and 30 miles per hour on the return with empty cars. What is the train's average speed for the entire trip? And we'll round. All right. Why are different speeds? Well, let me try to actually sort of enact this for you live. It's not a freight train, but I couldn't afford an actual freight train because they're really big and cost tens of millions of dollars. So instead, here's my rendition of a freight train. Notice this cargo. Well, the cargo, of course, is going to make things heavy. So as the train is delivering its cargo, it's only traveling at 20 miles per hour because it's so heavy, it's so heavy, it's so heavy. Gets to its destination, unloads all the cargo that weighs a lot, turns around, and now, since it's lighter, it can go faster. And that's how, in fact, it can go 30 miles an hour on the way back. All right, so that makes at least the question make sense. Now let's see if we can actually answer it. Great. So here that we have to remember is distance equals the rate times the time. Now we don't know how far it is from its starting point to its destination. Let's call that d. Well, that means that the train started at its destination, started at its starting point, went to its destination, and then came back. So it traveled d, and then d again, so 2d. So the distance it traveled equals 2d. D this way, and then d back. Okay, now, how long did it take to actually do this entire trip, going down and coming back? We want to try to find the average speed, so I want to know how much time was spent. Well, there was the time going, and then we were only traveling at 20 miles per hour, and we traveled d units. So if distance equals rate times time, then time equals distance divided by rate, which in this case would be d going one way, divided by the rate, which is 20. So that's the time it took us to go this way. What's the time it took us to go back? Well, we went back, still distance d, but now we did that in 30 miles per hour. So that sum gives me the time. All right, we know the distance, we know the time, we want speed, which is rate, and so we know that the rate equals distance divided by time. And that's what we want. And so what is that? Well, it's going to be distance, which is 2d, or not 2d. It doesn't work. It only works with 2b. You know, you'd think it would work with other letters. Divided by the time, which is d over 20 plus d over 30. Okay, and so now what we've got to do is we've got to figure out what this expression equals. That's the rate. That's what we're after here. By the way, notice all the d's. It looks like d will be in our answer. Let's see if that's really true or not. So what are we going to do here? Well, there's lots of, and 20 over 5, which equals 24 miles per hour. That's the average speed. Does the answer make a little bit of sense? Let's think about it. 20 going one way, 30 going the other way. And so, in fact, this is a number between 20. The average should be bigger than 20 and should be smaller than 30, so that makes sense. And so it's sort of right there in between, 24, and that turns out to be the correct answer.